So let's read the question. Well, a shipping company handle rectangular boxes provided the sum of the length, width, and height of the box is 96 inches. So this means that you're gonna have a box. This is a box. Well, when you have a box here, you're gonna have length, right, width, and also height. So when you have but you know the question say that you need to meet the condition that it sums, which is the sum of the length, width, and height is equal to 96. And then, well, the question say if you let x, y, and z be dimensions of the box, then the volume is going to be v equal to x, y, z. It does make sense because you know it's just length times width times height. So the question asks you to find the dimension of the box that meets this condition and has the largest volume. Basically, they ask you for the absolute minimum, or absolute maximum, sorry. They ask you for the maximum, right? Because they want the dimension of the box that gives you the maximum of the volume. Okay, so what are we going to do is, okay, we're gonna just follow the problem. So we're gonna set up, okay, one more time, let x, y, and z be dimensions, be the dimensions of the box. Well, because you know that its volume, right? The volume of the box is length times width times height is v equal to x times y times z. Well, you want the maximum, right? You want the maximum of the function v. But the thing is that you can see that the function v is a function in 3 dimensions now because you have x, y, and z. Well, is there any way you can reduce it into 2 dimensions? Because the problem say that, well, we have the condition x plus y plus z equal to 96, right? Because in the problem you have, you know, you have an information that the sum of the length, width, and height equal to 96. This imply c equal to 96 minus x minus y. Okay, and once you have c equal to 96 minus x minus y, which is good, so that means your v, this is a function of x and y. This is going to be x times y times 96 minus x minus y. Okay, this is a function of 2 variables now. This is the first step that you should do. It's just the standard trick that you reduce the function of x, y, z into 2 variable x and y. And then after that, you trying to find the maximum of this function v. So to find the maximum, first you need a critical point, and then you have to check that that critical point give you maximum, and then you can get the maximum of volume. So first of all, we're gonna find a critical point. So how do you find a critical point? So we set up differentiate v with respect to x, right? Well, basically you have to compute this thing first, and then after you compute, you set it equal to 0, and then you're trying to solve for that critical point. So we're gonna differentiate v with respect to x. So I do not need to differentiate y, and then I differentiate x times 96 minus x minus y. Okay, I have y here, so I differentiate this thing. I have to use product rule. Well, I mean, if you don't want to do that, you can make the problem a lot easier by just expand first. You can expand this thing to 96xy minus x square y, and then minus xy square. Well, this way you can avoid the product rule, because you already expand everything, and that means differentiate v with respect to x to get 96y minus 2xy, and then minus y squared. A lot easier, right? Because you just differentiate with respect to x. If you simplify a little bit, you can pull out y, so you get y times 96 minus 2x minus y equal to 0. Okay, that's the first. Okay, this is the computation of v differentiate with respect to x. You do another time we differentiate with respect to y, and what do you get is you get 96x minus 2xy. Sorry, minus 2x squared. 1 second. That is x squared y. So you differentiate with respect to y, so you get minus x squared. And then the last term you differentiate minus xy squared, you get minus 2xy. Okay, you simplify by pull out x, so you get 96 minus x minus 2y. Okay. Well, once you get the first derivative of v with respect to x and y, so you set up the first derivative equal to 0 and the first derivative equal to 0. Remember, this is where we find the critical point. You get the function v and then you differentiate with respect to x and y. You set it equal to 0, and then, well, you're trying to find the critical point here. So what is going to be the critical point here? That can you find? So the first one, if you set two equation to be 0, so you get y times 96 minus 2x minus y equal to 0. So on the first side, so differentiate v with respect to x equal to 0 here. You have two real numbers that you multiply and then you get 0. It means either y or 96 minus 2x minus y equal to 0, right? Because when you have a product of two things and then it's multiplied together and then you get 0, it means one of them must be 0. So that means y equal to 0 or 96 minus 2x minus y equal to 0. Well, that is for the first equation. So for the second equation here, we're going to use the green one. So you have differentiate v with respect to y, which is x 96 minus x minus 2y equal to 0. Here you're going to get x equal to 0 or 96 minus x minus 2y equal to 0. And then now you can match the critical point. Well, the first critical point is going to be y equal to 0 and x equal to 0. Right? That's the first one. So I'm going to copy this thing to the next thing. Oh, I think this one is what I just wrote by myself. So I can copy it to the next page, I think. Oh, I remember we have to do screenshot. Okay, good. All right, this is from the previous step. So then you can conclude that all critical points are, so the first one is when y equal to 0, x equal to 0, that's the first one. So the first critical point is 0, 0. Well, the second one is when y equal to 0 and 96x minus 2y equal to 0. Is that right? So if you match this and this, so you're gonna get when y equal to 0, well, you plug in 0 over there, you get x equal to 96, right? Because if you match this equation and this equation, you get x equal to 96, y equal to 0. Another one is if you match this equation and this equation is x equal to 0 and y equal to 96, right? Because you plug in x equal to 0 here, you get y equal to 96. Well, I got an email from some student that do we have to show this step by step clearly? The answer is no. I mean, if you can look at the equation and then you can solve it, why you can do it. 1 second. Why do I have that thing? Okay. Next is the last one. You can match this equation and this equation. Well, this look too hard to solve it by just the eyeball. So you can make the scratch paper here, and you try to solve for that. Okay. How do you solve these two equations? Well, maybe I'm gonna just this is my equation 1, this is my equation 2, so I'm gonna just multiply equation 2 by number 2. So that means if I multiply 2 with equation 2, so I get 192 minus 2x minus 4y equal to 0, right? This means I multiply 2 to equation 2, so I get that. And then you can see I have the orange one here and the yellow one here. So what I'm gonna do, I'm gonna just use number 2, this is called number 3, equation 3. Then I use equation 3 minus equation 1. So 192 subtract 96, negative 2x, subtract negative 2x. So this cancel out. And then minus 4y minus that. Okay, we're gonna do that. 192 minus 96. What do you get? 96, right? And then I get negative 2x cancel out, get 0. And then negative 4y, this is got negative 3y here, and then 0. So that's mean y equal to 32. And then that's going to imply that x equal to 32 as well. How do I know? Because if you plug in y equal to 32 back into any equation here, you're going to get x equal to 32 as well. So that is how we solve the last critical point. Well, what I just did here in the circle here, this is just from the basic, system of equation, how to solve these two equations here, x and y. Once you solve it, you get all critical points. So what is going to be your maximum? Okay, what is your maximum here? Okay, so let's compute the thing that we need to compute. If you remember from the class, I told you that you need to compute v subscript xx, right? And then you have to compute v subscript xy and v subscript yy. Well, this is going to be the second derivative test. So we have vx equal to this. If you differentiate with respect to x one more time, you're gonna get, well, you can look at this term. If you differentiate with respect to x one more time, this term gonna be constant, this term gonna be constant, so you cancel out. I mean, it's 0, not cancel out, it's 0. And if you differentiate this thing with respect to x one more time, you get negative 2y. So that means here you get negative 2y. All right, that's the first one. And then that second one, you differentiate this thing with respect to y. So you have 96. Okay, you can look at this one as well, whatever you want. So we're gonna do this. So you get 96 minus 2x minus 2y. Okay, 96 minus 2x minus 2y. And then the last one, vyy. So you're gonna have that. And then, okay, differentiate with respect to y one more time. 0, 0, and minus 2x. Okay. Well, you have everything here. Well, if you remember when you learn the topic here in the lecture, I told you to draw a table here, and then you're gonna have the critical point. Well, you have 0, 0, you have 96, 0, you have 0, 96, you have 32, 32. And then you have vxx, vxy, and then vyy. And then you have something called d, right? This is you have vxx, times v by y minus vxy square. Remember what you did in class, but in class I just used, you know, f, right? F x x f y y, and then minus fxy square. Okay, and then after that we're gonna compute this thing first. Okay, it's a long way to go. So vxx is, well, you plug in, this is 0, this is 0. I'm sorry, you plug in, you have negative 2y here, so you can see y is just here. So you plug in, this is going to be number 0, and then this is going to be number negative 192. This is negative 64. Okay, and next one, let's do vyy first. Vyy here, vyy gonna be negative 2x, which is this thing. So it's gonna be 0, and then negative 192, and then 0, and then negative 64. And then the last one is vxy here, okay, which is going to be the critical point here, and then you just plug in that number. So this thing you get 96. This thing you get well, 96 minus 192, so you get negative 96. Well, you can use calculator here, of course, if you want. The last one is 96 minus, well, let me use a calculator here. 96 minus 2 times 32, which is 64, and then minus 64, so you get minus 32. And then now you can compute your d, which is your discriminant. You know, multiply, you get 0, 0, right? And then you minus 96. So this thing is going to be negative. Well, all I care that the number is going to be positive or negative, because it's going to show me that this equation is going to be max or min. I mean, you mean the given point going to be maximum or minimum. Okay, and then after that, this multiply this, you get negative 190. Negative, you get 0, and then minus negative 96 square, which is actually negative as well, right? Negative as well. So, well, it seems like it's all negative because, well, this is also negative. This is also negative. And then also negative 64 times negative 64, and then you minus 32 square. So you can try, we get 64 square, and then it's 4096, and then you minus 32 square. Am I right? Did I do something wrong here? 1 second. That's 1 second. That is positive. Okay, that is positive. Your D is going to be positive. That is positive. Good. So you get here that your D, it's going to be, okay, which is good. Your D is going to be negative here, negative here, negative here, and 64 square, and then minus 32 square, so you get positive thing here. So if you go back to the theory part, so you can figure out which one gives you the maximum. So I'm going to go back to the theoretical part. What we just did in class, we show you that after you compute your D here, see that if your D is negative, that is not the local max or local min. It's gonna call saddle point actually. But if your D is positive, so you look at fxx. If fxx is positive, it's gonna be local minimum. If xx is negative, it's gonna be local max. Well, let's come back to our question. this thing is no. This cannot be max or min, right? The point that are going to give you max or min is going to be this point, because this d is positive. And once you look at the function, when you differentiate with respect to x 2 times, you get the negative side here. So this confirms that this point 32 give the maximum. Okay, and then now you can find the maximum of the box, the maximum of the volume of the box. So to conclude, this is here, to sum up, okay, the maximum volume is V equal to x times y times c equal to x equal to 32, y equal to 32. And once you get 32 for x, 32 for y, so your c gonna be what? So because they have to add up to 96, so your c gonna be 32 as well. Because you know that x is 32, y is 32, and they add up to 96. So your c gonna be, because you have this equation, so your c gonna be 32 as well. And that's mean 32,768 inches. Well, the unit, whatever unit they give you, cubic inches, I think, for this question. Well, this is the maximum of the volume. Well, which you know that it is attained at the point x equal to 32, y equal to 32, and c equal to 32. Does it make sense? Long way, but this is the question that asks you to apply the problem, apply the second derivative test into the real world. Okay. I have a question from in the chat from some student. Well, isn't it a rectangular? Well, when you have x, y, and z equal to each other, well, that means the box is just the perfect cubic, right? The perfect cubic box, because we have 32, 32, 32 here. It's still a box. What is the problem there? It's just a perfect, cubic. No problem there. When you get x, y, it's still rectangular. It's still rectangular. It's still a box. It's just because they have equal sides. What's wrong with it? So that's not the problem for us. Will there be a word question in the exam? Maybe. I have not written the exam yet, but if it show up to be the word problem, so you actually have to do it. But it's not going to be that long, because when I give you a word problem, well, I have to pick the one that you only have 1 or 2 critical points. So I do not expect you to have like so many critical points on the exam, because you only have 15 minutes to do it. So maybe when you solve the critical point, you're gonna get only 1 or 2 critical points, and then you can do the question, quickly. Okay, that's good. Any more question on this problem? Question 3. Okay, so if you don't have any question with question 3 here, we're gonna hold it here. We're gonna just do question 2 first. Let's do one more about critical point, because I think who asked for question 2 again? Coach Shimon. She sent me a direct message that she wants us to go over question 2. Okay, so we're gonna do another question 2, and then we can go to question 7 after. Okay, question 7 for Mida. Okay, well, question 2 first, up next question 7. All right, question 2 here. Okay, good. Screenshot. Okay, I know how to do it now. Good. I'm learning. Yes. Oh no. Okay. Whatever. We have it here. We have function already. It's fine. We'll find the critical point. Fxy equal to that function. Classify them by using the second derivative test. Okay. Well, the trick here is that because you have the product here, do not expand it. It's gonna be messy because anyway you have the function here. You know immediately that you have to find the critical point first. So that's mean you need to differentiate with respect to x. So I'm gonna pull out y and y plus 3 first. Because they are constant in terms of differentiate with respect to x. So what you need to differentiate is just only x times x minus 2. Well, once you pull out y and y minus 3 already, so now it's gonna be easier for you because now you can multiply this thing, expand that thing. Because now you just only x and x minus 2, right? And then you have y times y plus 3, and then that is 2x minus 2, which is going to be 2 times y plus 3 times x minus 1. Okay, good. And then f subscript y here, I put out x first. I want to touch that. And then here I have y and y plus 3. Okay, and then x times x minus 2, and then that's y. Then now I have y squared plus 3y. Then now I have x minus 2, 2y plus 3. Oh my god, it is not. It's 2y plus 3. Yeah, it's okay. Fine. Well, I cannot simplify more. That is fy. Okay, good. And then now we need to find the critical point first. You can see that fx equal to 0 when, this is equal to 0. This thing, the one that I highlight in yellow, in orange, this is equal to 0 when x equal to 1 or y equal to 0 or y equal to negative 3. Okay. On that side, you have x equal to 1, y equal to 0, or y equal to negative 3. And then another side, so for fy equal to 0, so this is going to be when x equal to 0 or x equal to 2 or y equal to negative 3/2. Okay, need to be careful of that because 2y plus 3 equal to 0 mean y equal to negative 3/2. Okay, so I have that. Now you need to make a pair. So first of all, when x equal to 1, you can pair it with x equal to 1, you can pair it with y equal to negative 3/2, right? This is how to pair it. So first you pair x equal to 1 and this, impossible because you cannot have two value of x. Pair this and this, impossible. Pair this, x equal to 1 and that, yes, it is possible. So the critical point, the first one, all critical points. So this thing gonna be, the first one is 1 and negative 3/2. The second one is y equal to 0. This is okay. This is okay. This is not okay. So that means you have 0, 0, and 2, 0 here. Just come from that and that. We get that. And then y equal to 2, y equal to 0, x equal to 2, you get that. The last one is y equal to negative 3 and that. Y equal to negative 3 and that. But not this thing together. Okay. So you have 0, negative 3, 0, and 2. Oh, no. 2 and negative 3. Well, after that, once you get all critical point, you can make a table like I did before, and then you can figure out what is going to be your conclusion. So by this, I mean you can differentiate one more time. So if I differentiate one more time, so I can start from that function that I circle, and then I differentiate one more time. So 2y, y plus 3, and then times 1, right? Just 2y times y plus 3. Because there is no Well, you just need to differentiate x minus 1 with respect to x, you get 1. And then fyy, and then fxy. Okay. Fyy, you're gonna get, you differentiate this with respect to y, so you're gonna get x times x minus 2 and then times 2, which is going to be 2x times x minus 2. Okay, not that terrible, right? And then the last one, fxy, so you're gonna have, well, you can start from that one and then you differentiate. Oh, a little bit tough. Okay, but we have to do that. No choice. 2y times y minus 3 times x minus 1. So we're going to differentiate with respect to y. So I do not need to differentiate 2 and x minus 1. I need to differentiate with respect to y of y times y plus 3, which you can expand it to be y squared plus 3y, right? And you differentiate that, you get 2 times x minus 1 times 2y plus 3. Okay. All right, that is all for fxx, fxy, and fyy. And then you can compute your d, which is fxx minus times fyy minus fxy squared. Right, and then you just make a table, you know, as we did before, like that. Right, the previous page here, and then you make a conclusion. So I will give you the answer here. You can double check with your, you know, you can work at home and double check there. So the point that's going to be the local maximum is going to be this point. Well, this is the answer in the blue pen here. This is local max. I'm sorry, this is local maximum. This point is saddle point. 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 Well, you can try to do that at home, but you know, when you plug in the number x and y into the function d, you're gonna get the negative number for these 4 points, which means it is a saddle point. They are all saddle points, but this term you're gonna get positive d, and fxx is less than 0. So that is local max. Oh, you can try. You can try. You can try. You can try it. Okay. Good. Any question on this thing? I think you know how to do that, right? In, you know, in concept that you know how to do that, but it just plug in number and make conclusion. Okay, next is question 7. Well, before going to question 7, so let's answer the question in the chat first. Okay. Well, I have a question from the Lapon. But she asked in Thai. Well, please. Well, you do not need to direct message me. If you want to ask something, just ask in public. So, you know, some students, they have the same question with you, but they are so scared to ask. So if you ask, you are the brave one. Thank you. Well, some questions still have a hard time to understand this step that I circle here. Why do I get this critical point? So, you know, you have the thing that I circled here that I wrote in black, and the thing that I wrote in green here. And then when you get the critical point, you just go one by one. When x equal to 1, so you pair it up. So x equal to 1 and x equal to 0. But you see x equal to 1 and x equal to 0, this is impossible to be a point, because you need one x, you need one y. No way. And then x equal to 1 and x equal to 2, this is no way. And then x equal to 1 and y equal to negative 0 to, yes, you can. This is the first one. Then y equal to 0, x equal to 0, yes, you can. Y equal to 0, y equal to x equal to 2, yes, you can. Y equal to 0, y equal to negative 0 to, impossible. Well, just do each one at a time, you know, just one at a time, and then keep going until you get all critical points. Okay. Well, I think we learned this thing in class too, so you can go back to You think in class, good. Let's see the question in the chat more. Is this the kind of question we need to expect in the final for question 2, club? Yes, this is the question that you expect to see on the exam for question 2. Or I want you to, no, not question 2. Question 2 is approximation, right? Question 3 on the exam. This is going to be this, the format that you're going to see that I ask you to identify the local max and local min. Okay. Well, before I go to question 7, anything else? You can open the microphone and speak if I missed something. About 16 students, 15 to 16 students here. Any questions here? No question at all for this thing, good. Well, again, before we move to integration for question 7 next, so we're gonna just wrap up the thing here that, well, what you should practice for differentiation chapter 1 more. What you should practice is, first, you need to know how to compute limits and continuity into limit and continuity into dimensions. Those questions, they are multiple choice. So I will ask something, some easy question on the multiple choice about limit and continuity. You already did that on the quiz. So on the final exam, it's gonna be just the easy multiple choice. Make sure you know how the concept that when you want to show that the limit does not exist, you need to have one thing that you can show is you can pick 2 lines. Once you pick 2 lines and then you get different limit, it's gonna be the conclusion that the limit does not exist. Okay, and yeah, that's the concept that I probably asked on the multiple choice, that you understand this concept or not, or the thing that you pick your F and your G, so your squeezing theorem into dimension, that I could ask that, hey, once you pick your F, once you pick your G, do you know why you can bound F by 1 or something like that? Well, if you understand, the steps in the solution, in the example, in class, you should be fine to do that. Okay, that's limit and continuity. And the next thing that you need to know is you need to know how to differentiate by using the formula. Just the basic one, differentiate using the formula into dimensions, which is called partial derivative. And then once you know how to differentiate by using the formula, then you can do the show your work part. So your work part gonna be approximation, gonna be the second derivative test, apply to find local max or local min, and it's gonna be the chain rule. Okay. Well, you can expect that 3 question, show your work question on the exam gonna be similar to this type of question. It just kind of almost similar to this thing, but maybe I change the function, change what I asked or something, but well, you should be able to do it if you know how to apply the chain rule, how to check the second derivative test, check the max and min by using the second derivative test, and you know how to approximate something by using differentials. Okay, that the first part, differentiation. All right. Well, I'm not going to come back to differentiation again. Well, last chance, any question about differentiation chapter before we head to integration? Last chance, anything else for differentiation chapter? 5, 4, 3, 2, 1. Good. Okay. Sounds good. Hope you feel better. Hope you feel you're more prepared for that chapter. Okay. Next, we're gonna look at integration chapter. Okay, now let's see. Well, for this chapter, what you expect for this chapter is you need to know how to reverse the order, the x, dy, and dy, dx. That is going to be the big part that I ask you for the exam. Well, you can see that on the quiz, I also asked you to switch the x dy to dy dx. Well, that is a key concept that you need to know how to do that. Well, you need to draw a picture. That is the key point. Well, if you don't draw a picture, you will not get the full credit. Similar to the quiz, some of you may think that, hey, why do I get a low score on the quiz? Well, because you do not give me a picture and you do not share the area. You just copy someone else and you just submit it to me without checking anything. That's why you get low point. That is, but I mean, for those of you who stay with me here in the live class, I think all of you get good score. But for those of you who missed my class, they just get low score because they didn't follow my step at all. They didn't give me a picture or something, so that is why they get low score. But keep in mind that when you show your work, you have to show everything. You have to draw a picture. You have to label the line on the graph, and then you just need to explain to me. You use the x dy or dy dx because you use the vertical line or horizontal line or something like that. Make sense? Well, we're gonna do question 7 very quick here, and then after that we're gonna if you don't have any question on integration chapter, we can move to differential equation chapter. Okay, we're gonna do question 7 first because I think who said that? Nida, right? So Nida wanna do question 7. Salataya is question 11. Or that another topic. Okay, let's do 7 first. Well, I give you a picture here, but you read the question. The question say express a double integral you would use to find the area of R. Do not evaluate the integral. So you do not need to evaluate the integrals. Okay. First of all, you look at the picture here. You have the line y equal to 3x minus 9. And you also get the green one here, that you have y equal to 2x. Well, actually you have another one, the orange one here. This is the x-axis, or y equal to 0. Well, we're gonna build up the area R here. Okay. Which one is easier, the x dy or dy dx or the r d theta? That is the thing that you should answer yourself first. When you do the question, what direction you're gonna do? The x dy, dy dx, or r d theta? Well, for sure, this one, you're not going to use polar coordinate because it's terrible. It's not that terrible, but it's gonna take time for sure, because you just need to convert this thing to polar as well. Well, we're gonna just cut out polar first. Remember, polar gonna use for circles. Mostly you're gonna use for circles. So we're gonna, this is not a good choice. Well, let's do the x dy or dy dx. But well, in the chat, Shruti said that, well, let's do the x dy. Why is that? Because when we draw the horizontal line here, you can see that you do not need to separate the region at all. So you can go from the green line to the light blue one all the time. So that's I can do that easily by integrate, area, you use 1 here. And then the x dy. Okay. And then x gonna be from the green one, the green line, the green curve here, the green line here, which is x equal to y over 2, because you already simplify it. So y over 2 here. And then on the right hand side, so it's gonna go to the blue one, which you have to reverse this thing. This is x equal to y plus 9 over 3. Okay. That is going to be y plus 9 over 3. And y going to be the range that you make a horizontal cut, which is going to be y equal to 0 to y equal to 80. Okay. Sounds good. Well, one thing that you can check your answer by, make sure that the outer integration here gonna be numbers always. Some of you, when you do integration, you get x or y on the boundary here, which is for sure it is going to be not correct, because if you get the correct answer, your outer boundary here must be a number, otherwise you cannot integrate, right? Does it make sense? And when you have the x here, you cannot have x here. Well, some of you are gonna say dx and then you use 2x here again. No, you cannot have x here, because you can think that when you have the boundary here, this thing gonna be the thing that you're gonna integrate next with respect to y. That is why you can check easily that, hey, your answer makes sense, because after you integrate this, you're going to get a function of y, and that's going to be the term that you can integrate with respect to y after. Okay, we're going to do one more here. Well, I saw circle here. Well, you can use polar coordinate if you want, but because I think this question is maybe a lot easier again to use the dy dx, dx dy, because you also have a line here. Well, I don't want to mess up with the line here, because if I choose polar coordinate, I have to simplify this thing to polar coordinate, which I try to avoid that thing. So because of that, I'm gonna still using the x dy or dy dx. Which one is easier? You can think, well, vertical line mean here, not that easy, because you have to separate into two pieces, right? It's the first piece and the second piece here. But if you do the horizontal line, looks like it's gonna be okay, right? Because every time you go from the black one to the purple one all the time, well, not that bad. So we're gonna do the x dy as well. Okay, start from that line to that line, that line to that line, that line to that line. So x gonna be from here is x equal to y minus 5 over negative 3, which is 5 minus y over 3. Okay, 5 minus y over 3. Okay, that's the left one. Okay, the right hand side, you have that curve in orange, which is this. This is actually the circle, x equal to square root. Okay. This is already the form we want. So good. Square root 25 minus y squared. Okay, good. I don't have to do anything. And then y is going to be from this point, -4, right, to this point, which I need to find a range. Okay, let's look at that again. To figure out the range of y, I need to make sure that what is the range of y that I do the horizontal cut here. You can see it is -4, which is this point, up to this point on the top here. But the point at the top here, I need to find the cut here. Well, this is the cut that you can cut the circle here with the y-axis. So when x equal to 0, you can see that y equal to 5, right? Because when x equal to 0, y equal to 5, because you can solve the equation, and that means, well, at the top you get -5 here. Well, at the bottom you get not -5, and this is -4. All right, this is going to be your answer for this question. Okay, integration is not that hard. I think you can do all questions easily. Well, let's see, we have, if we have any question. Well, any question on integration chapter here? Any question for integration chapter here? Well, Natakiat asked in the chat that, can you integrate x, y, cosine x, y plus sine x, y dx? What is that? Is that integrate in 2 dimensions or 1 dimension? I don't get it. Well, re-ask the question if you want, because I don't get your question. And in English, please, because we have international student here, so they can see it too. Okay. Anything else? Anything else for integration chapter? Well, question 14 is for question 14, that is differential equation. We're gonna come back to that one, but any question on 6, 7, 8, 9, and 10? Anything? No, right? You good with integration chapter? Okay. Well, I don't think we do not need a break, I think, right? Because we just keep going, and then at 2:30 we're gonna just cut off and then we're done. Well, the last chapter here, 11 to 15. All right. Well, before we head to differential equation chapter, any question on differentiation and integration chapter? Last chance. 5, 4, 3, 2, 1. Anyone? No? You good? Well, I already did number 7, not to get. Oh, but change it to polar. No, I will not do that. It's just a terrible one. Well, you can do it, but if you use polar coordinate, you see, question from not to get is, can you do it with polar coordinate? If you do it, you see that you're gonna do like that, 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 right? The hard part for polar coordinate is you need to convert this equation into polar coordinates. And when you do the polar coordinates, you need to start from this theta to that theta. And this theta gonna be the worst one that you need to find the angle, because the number here is 3 and -4. So the angle is not going to be the easy one. It is not going to be pi over 3, pi over 6. But the angle gonna be something that you cannot solve it by hand. You need to use calculator. And it's gonna be just arctan of 3 over 4 or something. So using polar coordinate is not a good idea for this question, because it is terrible to find the given start point here. Okay, can theta be negative? Yes. Yeah, well, this theta gonna be -1 because it's just under the x-axis here. Well, even I see the circle here, but because of the behavior of the line here, I still prefer to use the x dy. Well, yeah, because this question asks me not to evaluate that, so I have no problem, because I do not need to evaluate this thing. I do not need polar coordinate here. Good. Well, so answer to another gear question, so I'm gonna skip that one. Skip choosing polar coordinate that. Okay, good, but that's good question. Thank you. All right. Anything else on the first 2 chapter? Again, differentiation and and integration. So I'm not going back to that one again. Okay, we're gonna do the last 2 questions. I think people asked us to do question 13 and 14, right? That's what you want, because last time we do 12 and 15 already. So we need 13 and 14, and that's all for today. Sounds good? Okay, anything else? Good. Okay. Okay, so no question. So we're gonna move to question 13 and 14. Okay, 13 and 14. Oh, Salataya say 11. I forgot. Well, 11b as well. So let's do 11b first. Start from the basic one to the hard one. Okay. Well, can you tell me what is the type of the equation in the question 11? What is the type of differential equation in the question 11? Nida says separable. Anyone agree with Nida? This is separable equation. Agree, right? Yes. So, well, you can see that you can simplify this thing to, move everything to the left-hand side with respect to y here. And then move everything on the right-hand side with respect to x here. Well, yeah, separable equation easily. So you integrate it on both sides. Well, this type of question gonna be multiple choice question. Does it make sense? Separable equation gonna be on the multiple choice question because it's quick and easy. You can just group, and then integrate. You expect to see this type of question on the multiple choice, but the function is not going to be maybe easier than this thing. So you can just do it in 1 or 2 minutes. Integrate cosine, you get sine here. Well, I'm gonna just plot c at the end. Well, here you're gonna okay. If you want to be more clear, so you get 1 over y minus 2y here. Okay, integrate cosine x dx, and that is log absolute y, and then minus 2y squared over 2, and then sine x. Well, actually, I need to add c on both sides, right? But we're gonna group it to be just 1c on the right hand side. That's fine. And this is your general solution. For this question, we have y0 equal to 1. So you need to plug in the value. This means when x equal to 0, y equal to 1. So when x equal to 0, y equal to 1. Log 1 is 0, right? E to the 0 is 1, and this is 1. This is 0. So plus c. So that means c equal to -1. Okay, you get the answer. So a particular solution is log absolute y minus y squared equal to sine x minus 1. Particular solution, or in other words, specific solution. Easy, right? Good. Separable equation. Sarataya sounds good for this question. Okay. If you have any question, let me know. We're gonna move to the next one. 1 second. What do you want first? 13 or 14? Let's do 13 first, then step. Okay. 13. All right. Take screenshot. Copy. Solid. And okay. Here. Okay, we got it. Well, let's suppose that I don't give Pokemon Go. Oh no, my photo. Okay, next is, well, let's suppose that you don't know if this equation is homogeneous. Suppose that the question didn't say anything. So, well, it is, well, some student asked me that, well, do I give you the information that the equation on the exam going to be homogeneous or exact? Well, I have not decided yet, but I'm gonna, well, I think that one question is gonna give you the direction, immediate direction that, hey, this equation is this type, do that. But, well, maybe another question, I'm gonna say no, well, I'll just give you the plain thing here and let you figure out by yourself, But anyway, just assume that I don't give you anything, so you have to figure out by yourself. When you don't know anything here, you just need to do the separable equation check first if you can separate it. But you can see cosine y over x here. This is a sign that you cannot do the separable equation because anyway you can separate y and x here. It is inside the cosine function, so you cannot separate it. no way to be separable equations. So let's try to simplify it to the form that we have as standard form. So we're gonna multiply the x with the equation. So multiply the x. So we get x dy minus y dx. Well, let's see, for those of you who cannot follow me, I'm gonna multiply the x with the equation, so I get the x here. So the x cancel out. Then I'm gonna just multiply the x here. So I get minus y dx, and then I multiply the x here. So I'm gonna get x cosine y over x dx. Okay, sounds good. I multiply dx to the equation, and then after that I simplify, move everything to the left hand side. Let's move to the right hand side first. So I'm gonna x dy equal to x cosine y over x plus y, and then dx. Okay, and now after that I move that term to the right hand side. So x cosine x y over x plus y dx, and then plus minus x dy here. So this is going to be my function m. This is going to be my function n. Well, this is a standard form already, m dx plus n dy. So, well, for sure you have two choices. Either it's homogeneous or exact differential equation. Well, we're gonna do homogeneous for this question. Well, for homogeneous, you're gonna say that, hey, I check mtxty first. Well, you can check it by yourself. You're gonna get t times mx my mxy. Well, it's not the terrible check, but once you check it, so you can conclude that m is homogeneous of degree 1. And then you have ntxty. Well, this is not a terrible check as well. So this is going to be t times nxy. Well, also n is homogeneous of degree 1. Okay, so the degree here are forced to be equal to each other to go to the next step. So now you have homogeneous equation. Good. Well, this means this differential equation is homogeneous. Okay. Next, once you know that it is homogeneous, what is the next step you should do? You remember? If you cannot remember, just open the book. You know, this is an open book exam. Y equal to Vx, then dy equal to V dx plus x dv. You start this way all the time, and then after that you plug in this thing back, and it's gonna be separable equation. I'm gonna just copy this one. Okay, we're gonna plug in now, so it's gonna be x v dx plus x dv. All right, and then x cosine vx over x, and then plus vx dx. You pray that something gonna cancel, please. Something cancel, please. Let's see if you have something cancel here. We have x v dx plus x squared dv, and then here we have x cosine v dx, and then plus vx dx. Yes, this thing cancel out, right? You have the same term. Well, even you don't have something to cancel out, you can group everything in terms of v to one side, everything in terms of x to another side, and that would be the way you solve this problem. So now we're gonna move everything in terms of v to one side. So I move that to, well, I'm gonna move v to left hand side. Gonna move x to right hand side. I have 1 over x dx. I have secant x, secant v dv. Integrated, you get log sec v plus tan v. Well, how do I know that I get log sec plus tan? Well, look at the question. This is the hint for you because it's give you in the question. Well, if the integral is hard to do that by hand, I'm going to give you the formula so you can just, you know, pick it from here. Then after that, okay, integrate 1 over x. What do you get? Log x, right? Plus c. Okay, this is a general solution. Is that the answer? Just that it? Yeah, that's it. Just asks you to solve the following differential equation. However, if you leave the answer in this form, you still need one more step, right? This will, well, out of, let's say this is out of 10, you're gonna get 9. You're almost there, but the last step that you always forget, some of you always forget, is just switch v back to y and x. So v is y over x. Plus y over x. And then log x plus c. Well, this is the final answer. All right. Any question on this solution, homogeneous differential equation? No? All right. Well, if you don't have any questions, so we already live for 1 hour and about 10 minutes. So, well, you are tired now, I think, but let's stay with me one more question. The last one, 14. All right. Oh, looks terrible, huh? Okay. Maybe I need to use so many pages. So I'm gonna add one more and one more. Okay. Who already did this question? Who already did that? Is it easy? I have not done it. I just picked this question on the book. It's okay, right? Yeah. Okay, let's do that. Let's check the answer together. All right. Well, yeah, if you already did it, let's check the answer together again. So, well, the question said clearly that this is a test of exactness. So, well, for sure, this is going to be the exact differential equation. So we're gonna say, wow, this is easy because you already have m and n here. Okay, so we're gonna just differentiate m with respect to y and n differentiate with respect to x. Hope they are equal, so we can conclude that this differential equation is exact. So we're gonna differentiate with respect to y. Oh my god. Product rule. X and then y. Well, did I go too fast? Should I slow down? Okay. Well, it's can I go faster a little bit? So x, I do not need to differentiate x, right? And then I differentiate y here. So I need to use the product rule to this term. So it's gonna be x, and then I keep y. I differentiate cosine xy. And then I keep cosine xy, and then I differentiate y, which is 1. And then plus differentiate sine xy, so you get cosine xy, and then x. You know, the differentiation is not hard, but it's tedious. It's just so much thing to do. It's just tedious, but not hard. All right, next I need to differentiate that. Differentiate cosine, get negative sine, and then I have one more x, and that is x cosine xy 2 times, so I have 2. Okay, I simplify everything. Well, hopefully this is a good one. Okay, good one. All right, next, n subscript x. Well, differentiate the second term with respect to x. Did it something wrong? Okay, differentiate with respect to x. So you have that and that, but e to the y is just constant now in terms of x. So get 0. But the first term here, you apply the product rule. So gonna be x squared differentiate cosine xy, and then cosine xy differentiate x squared. All right, I have a hope because on the second term here it matched good, right? Because differentiate this you get 2x, and then on the first term here you get x squared, and then hopefully it match. Integrate different cosine, you get negative sine, and then you have y left. Yes, good. So my equal to nx. This equation is differential equation is exact. Well, if you skip this step, if you just go ahead to the next step without checking the exact differential equation, you're gonna lose at least 30% of this question, because this is the important part for this question. You have to check first if the definition is exact. Next, we're gonna what we can claim now, the general solution is fxy equal to c. But we're gonna find function f. Okay, function f. Well, we're gonna do the next page then. So what do you want to do it? Do you have to integrate that, right? Oh, it looks terrible. So you have fxy equal to if you differentiate with respect to x, you get m. If you differentiate with respect to y, you get n. Okay. Well, usually what we do is we're gonna just start from this equation f differential with x equal to m, right? And then I integrate function m with respect I integrate m dx, so I can get my f. You can see that is one way you can do, because you can just start from m and then you integrate m with respect to x, right? And then you try to get back to the thing you want. But I see the problem I see the hard part over there, because you have x cosine y xy, and if you integrate with respect to x, this x and this cosine x could be a problem for you, because you may need integration by part, because you have polynomial and cosine multiplied together. Well, if you a little bit smarter, so you can think that another way you can do it, why don't you start from f here, and then you just integrate your n with respect to y. Now, two ways, right? You can do that. Well, is it easier if you do this thing, integrate with respect to y, so it return f as well, right? Well, two ways to return f. You can do f is integrate m dx, or you can do f integrate m dy. Which way is easier? You use that one. If you use that, well, actually it is not that terrible if you are expert in integration by parts here. But some of you avoid by part, right? Because you say, when you heard something about integration by part, you're like, it's just going to be hard for sure. But by part is easy, integrate u dv equal to uv minus integrate v du. This is just a simple by part. Well, and this is just x cosine x. So if you integrate by part, you're gonna get some complicated statement over there. So we're gonna just do the alternative way first. All right, so we're gonna start from, let's see my solution. I'm gonna do f differentiate y, we get n, right? So that means I'm gonna say, okay, if I want f, I just need to integrate n back dy. And then, well, I'm gonna do by part later after this. For this, this is the first method. Well, I'm gonna show you both way. Well, one way, maybe this one is easier. We're gonna just see fxy equal to that, and what else? I forgot the function. Where's my function? N is here. Okay, n is over there. So it's gonna be x squared cosine xy plus e to the y. Okay, that is my function for my n, right? And then let me check again with the question. I don't want to copy it wrong. Where's my review packet? Okay. Well, yeah, I did something wrong. Okay, x squared cosine xy plus e to the y. Okay, that's right. Now we're gonna just integrate it. Okay, integrate x squared. X squared is constant. I don't have to do anything else with that. But what I'm gonna do, I'm gonna split it first. So integrate x squared cosine xy dy. So x squared just out because I do not need to get that. And I integrate cosine xy. Well, dy here I'm gonna use dxy here, and then I have x here. Well, this is the term that I try to do a substitution by pick u to be xy. So I get that, and then plus integrate e to the y dy. Okay, let's keep it like that first. X cancel one time, and then you're gonna have integrate cosine, you get sine xy, and then integrate cosine, you get sine, yes, and then plus integrate e to the y, you get e to the y, and then plus some constant, which is a function of x. You know, because you integrate with respect to y now, the constant gonna be a function of x. Okay, I have that function f. My f gonna be x sine xy plus e to the y plus hx. Okay, I'm gonna differentiate that with respect to x, and hopefully it's gonna be m. Okay, I differentiate with respect to x. Well, x sine y, so I get x cosine xy, and then by the chain rule I have one more y, and then plus sine xy. Differentiate with respect to x, so I get 1, and then 0, and then plus h prime x. Well, actually, this is xy cosine xy, and then plus sine xy plus h prime x. But your m is that function xy cosine xy plus sine xy. Wow. That is just m. Okay, that. Your m gonna be just xy cosine xy plus sine xy. All right, good. And that means your h prime x is 0. Well, basically your h is just constant. Well, this is just completely a constant. Good. Well, that means your function f at the end gonna be just the term that I highlight in yellow here. And at the end, my general solution, the general solution is x sine xy plus e to the y equal to c, some constant c. I think this is the easier way. Okay, this is the answer. However, if you go the tough way, it's still okay. So I'm gonna do the second method. What if you start from f subscript x equal to m? Will you get the same answer? Yes. Let's do that. F integrate m dx. Well, your integration may be a little bit tough. What is my m? Xy cosine xy, and then plus sine xy dx. Okay, I got another get question now. This is what you asked, right? How to integrate that. Okay, so first of all, I'm gonna split it to two parts here. Okay, so we're gonna do the hard one first. Is number 1 by parts. Okay, before doing by parts, you can move y out because y is just, I move y here. Just kick y outside because I don't want to see it. Terrible. So I have integrate x cosine xy dx. if you want to do by part, so you let u to be x, dv to be cosine xy dx, and then du equal to dx, and then v equal to integrate dv, which means integrate cosine xy dx, and that means integrate cosine xy dxy over y. Okay, and that means 1 over y sine xy. Okay, by using integration by part, integrate x cosine xy dx using by part, it's going to be u times v minus integrate v du. Du is here, sorry. That is u dv uv minus integrate v du. Okay, and that is, well, you know, such a terrible thing, sine xy, and then minus, well, 1 over y, you don't need to integrate sine xy over integrate sine xy dx, right? So you get 1 over y negative cosine xy. Well, you can, I did it fast because I integrated very quick, but you know, when you do it, it's gonna be a little bit slower because maybe you already forgot by parts or something. That is why it looked terrible for you. But technically, it's not that hard. It's just because, well, we already did by part a semester ago. It's take a while to recall that technique. Let me see if I integrate sine. Okay, integrate sine, you get negative cosine. Good. And then after that, I have that function. Okay, simplify it, x over y sine xy, and then plus 1 over y squared cosine xy. Yes, look terrible. It's terrible. And then after that, we have integrate cosine xy here, dx, which is actually, one second, why don't we just group it and can, oh yeah, I did the hardware already, fine. So I integrate sine xy here, so I get 1 over y, integrate sine, I get negative cosine xy. Okay, that is how I integrate that term. All right, and then after that, you know, it is not fun to do this way. Next, we're gonna have, well, let's do it. So we're gonna have this term, right? I highlight yellow. I'm gonna pack in the yellow thing into that one. Well, but don't forget you have y here. So something gonna cancel out now. I can see it. So we're gonna copy that, my f, okay, to the next page. Okay, this is my f. Well, I'm gonna just replace the yellow one by, I just keep y here, but the yellow one here, I'm gonna just get it from integration by part. Come on, copy, and that. All right, and then that's the second part. It's going to be that one. Okay. Okay, something gonna cancel out. Good. Okay, copy everything I have what I want now, and then plus some constant of y, because this is still a function h y. Okay, well, get x sine xy, and then plus 1 over y cosine xy, and then minus 1 over y cosine xy. Ooh, cancel. Then get plus hy. All right, this is my f, and then I can differentiate f with respect to y. Set it equal to n, right? Your n gonna be differentiate this function, just this one now, with respect to y. So you get x, differentiate sine, you get cosine, and then times x, because of the chain rule. Okay, you differentiate this thing with respect to y. Okay, and then after that plus hy harm y. Okay, this is x squared cosine xy, and then plus h harm y. Okay, but your n from the question is x squared cosine xy plus e to the y. X squared cosine xy plus e to the y. Well, this means h prime y equal to e to the y. Okay, hy just e to the y then plus some constancy. So you replace this thing back to conclude. So you have f equal to x sine xy plus e to the y plus c. And you got the general solution now. Is x sine xy plus e to the x equal to some constancy. Okay, so you can see that you have two ways to do it. The first or the second method depends on what you prefer to integrate. It's just a trap that if you do the x, it's gonna be by part first, which you take a detour, and then you just get back to the part after. But if you just do fy equal to n first, integrate n dy first, it's a little bit easier. Okay. All right. Any question on this thing? So some question from student gonna be, hey, is the question on the exam gonna be tough like this? Maybe a little bit easier compared to this one, but still tough. Yeah, for sure. Still long for sure. Well, because you still need to check exact differential equation and need to integrate. Well, if you are weak in integration, it's gonna be hard for you. Well, but my question, I do not expect you to use by part. I do not expect you to use fancy integration technique. So you expect to just integrate polynomials or use substitution. That's all. All right. Any more question on the class or on the review? We have about 20 minutes. If you have any question,